we can move forward with Professor Steve Scott. Thank you very much.
Thank you. Thank you, Pedro. Ladies and gentlemen, the last speaker of the previous session is a Canadian, Michael St. John. And I'm a Canadian, but I come from Canada. He comes from Europe. But at least now the interpreters are accustomed to the Canadian accent, so there shouldn't be any problem. I also come from the city of Toronto that has, in the last census, 113,000 Portuguese in the city. And I would imagine that at least half of you here have either a relative or a good friend who lives in Toronto. At least that's what I find when I travel around in Portugal. Well, I'm here to talk about the mineral resources of the deep sea. And let's think a minute about our planet. You know, our planet is covered 71% by water, ocean water for the most part. And 60% of that is at depths greater than 2,000 meters. And it is full of resources. We know that. We don't know how much is there. We don't even know if we can recover it yet. We'll say more about that later, but we know they are there. And in fact, there's so much water on our planet. Why do we call this planet Earth? It's planet ocean, for sure. And you Portuguese recognized this many hundreds of years ago when you looked outward to the rest of the world, and famous explorers and so forth. And now you're looking, from this conference, you're looking outward again into the oceans as a way of developing some economic activities and so forth. And that's what I'm here to talk about. So first, there's the 3 points on the screen. What are the deep sea mineral resources? And secondly, and sometimes shallow sea too, I'll get into that. Where are these within Portuguese waters? I mean, how many of these do you have? And thirdly, to take a look at this question of protected areas versus multiple use. I mean, are they compatible? I think they are, but we need to explore that a little bit, and I think that's what we'll be doing a bit in this conference. Well, what are they? Everybody knows about the manganese nodules. The best ones occur in the so-called Clarion-Clipperton zone, which is off between Mexico and Hawaii. But they are known in the Atlantic, but the Atlantic hasn't been explored very much for these. And these contain interseam concentrations of nickel, and of copper, and of cobalt, 3 metals that are used in industry. And then there are the iron manganese crusts that occur on the sides of seamounts. And there are thousands of seamounts in the ocean, including in the Atlantic. And these contain interseam concentrations of cobalt and nickel. Then on the continental shelves, including your continental shelf, there are methane hydrates. These are gas hydrates that they're basically an ice that you can hold in your hand and light a match to it, and it'll burn because of the methane in there. And it's a future energy source. The crusts also, in the bottom right photograph, the crusts also have a layer of calcium phosphate, of apatite. It's a phosphate that's used for fertilizer. Plus there are phosphates probably on your continental shelf, because anywhere you have upwelling of ocean water, you develop phosphates. But I don't think there's an awful lot known about them. I couldn't find much about this when I checked with Google this morning about phosphates in Portuguese waters. But the important ones for you people, and what Jonathan Lowe, who's speaking after me, is going to address, are these hot spring deposits of copper, zinc, silver, and gold that are forming on the present-day ocean floor. And in the bottom right is a video running of one of these hot spring deposits. It's called a black smoker for an obvious reason. It looks like a dirty industrial process. And all the mound material you see there are precipitates coming from that water, which is, in this case, about 360 degrees centigrade. And it contains mostly minerals of no value, but in some cases, concentrations of the copper, zinc, sometimes lead, silver, and gold that are potentially economic. And you have several of these in the Azores area, because the Azores sits on or beside the mid-Atlantic ridge. This is where the ocean floor is splitting apart at about 2 centimeters a year. It's an area of active volcanism, therefore lots of heat, and therefore producing these black smokers, if I can get it back again, that you have. This is the rainbow one, which is just south of your exclusive economic zone, your current exclusive economic zone. And they occur other places in the world too. And I'll point out on the Pacific, over on the left side of the Pacific, that's where Nautilus Minerals, which Jonathan Lowe, the company he's with, intends to mine a deposit soon. And it's a deposit in which an Australian colleague and I discovered in 1996, doing pure research. We weren't doing prospecting, we were doing research and happened to have found a rather interesting deposit. Well, this is your situation. The black lines are your currently accepted exclusive economic zone. The faint yellow line, and I hope you can see it, is the extension for which you've made application to the UN, and expectation is that, in fact, you'll get this, maybe not all of it, but you'll get most of it, and that will probably happen in about 2016. The application went in some time ago. And you can see you have iron manganese crusts with their nickel and cobalt and platinum metals. You've got manganese nodules. How many? Don't know, because it really hasn't been explored that much. You have these mud volcanoes that are releasing methane hydrate, so you've got these gas hydrates as well. And perhaps more importantly, in the area of the Azores, you have these so-called seafloor massive sulfides, these copper, zinc, silver, gold deposits. And there are 4 of them within your present-day exclusive economic zone. And there's a new discovery to the north called Moitira, right near where the upper arrow is, and it was just discovered this year. That'll be in your new exclusive economic zone. And then Rainbow, which is what the video was, just to the south, and it'll be in your new economic zone as well. In fact, your new economic zone is going to add 2,150,000 square kilometers to your territorial waters. Now, that puts Portugal at position number 11 in the world, and it means that you will have 42 times more territory offshore than you do on land. You become a big country because of this. Well, are these mines the future? I'm not going to dwell on this because Jonathan Lowe is going to discuss this after me. But I want to point out, though, what an ore is. I mean, just because something is rich, and maybe even big, on the seafloor or on land, it's not an ore unless you can recover it and make a profit doing it. You know, so it's just otherwise just an interesting discovery. So keep that in mind. You know that it's these things we know. First of all, we don't know enough about the ones that you have. What we do know is they're fairly small, but nobody's explored extensively enough to know how big they might be. But more importantly, you know, if they cannot be recovered economically, they are not ores. Well, I think there are some real advantages to mining in the oceans compared to mining on land. First of all, the mining in the oceans, as you will see, will be done with robots. And so there's no shaft to sink, no underground workings, no big holes in the ground, no big piles of rock beside those holes. There's no town to build, no power plants. The infrastructure is totally reusable. You mine one deposit and you move over to the next one, taking everything with you. On land, you have to leave those things behind. Also, you can do what is called surgical mining. You see the photograph is a very small seafloor massive sulfide mound. You notice that there's no sediment on it, on this particular one. In fact, mostly they don't have a lot of sediment on them. Some do, but many of them don't. And so you'll mine just that deposit and not remove a whole lot of rock. The ratio of waste rock that is removed to a ton of ore in a mine is called the stripping ratio. Nothing to do with sex clubs or anything. It's to do with a mining term. And the stripping ratio can be anywhere from 3 to 7 to 1. That is, you're going to remove 3 to 7 tons of waste rock for each ton of ore you recover. And it costs just as much to mine a ton of waste rock as it does a ton of ore. And so we can also mine small deposits because you're just going to move from one to the other. The miner is not going to be the kind of miner we know today with hard hats and rubber boots on. They're going to be engineers, robotic engineers, electrical engineers, electronics people, and so forth, on a ship running these robots on the ocean floor. And because nobody lives on the ocean floor, there's not going to be the social problems of disturbing where people live. We always have those problems when we develop mines. Now, the Nautilus deposit, Solara 1, covers an area of about 0.11 square kilometers. If we contrast that with Neves Corvo, which is just south of Lisbon here, it covers the surface plant, the surface operation, covers an area of about 2.6 square kilometers. Now, that Nevis Corridor is much bigger, but still, the point is that in terms of sustainability, mining in the oceans, in fact, is probably an advantage over mining on land. Well, I'm going to continue or finish by simply saying, we have this expression, we have it in English, and I've been told you have it in Portuguese too, that the pot of gold at the end of the rainbow, and remember this deposit rainbow sitting on just south of your area, well, it may be on the ocean floor. Thank you. Obrigado.